Class 10. Pay attention. This is exercise 13.3. You can go back and check the first lesson for the theorem. Okay. This is based on that area theorem. Okay. This is based on areas. Fine. Look at number 2. Okay. Most probably I'm doing the even numbers. Okay. Right. Check. Triangle that is similar to triangle that. Now remember one thing. One thing you must remember, that whenever they say that two triangles are similar, like here ABC is similar to DEF, triangle ABC, triangle ABC is similar to DEF. Follow the book for the sum. Okay, now when they say similar, we take it for granted that A is equal to D, the first one is equal to first one, second one is the second one, and third one is third one. Okay, first one is equal to the first one, A is equal to D, B is equal to C, B is equal to E, and C is equal to F. We always take that for granted. Okay, and then they say ABC is 9 square, find the, and area of that is 16, BC is 2.1, find the length of EF. Find the length of EF. Now, there, triangle ABC by triangle that is equal to BC square. I'm taking this straight away because this and this angle this side, this angle this side. So BC square is equal to EF square. Straight away I'm taking that, which is equal to 9 by 16. This is given. Now BC is 2.1 whole square is equal to EF whole square is equal to 9 by 16. Now what you can do is you can take the square root of both the sides and this will become 3 by 4. Calculate it and you will get your EF. No big deal. Is that okay? Question number 4. Triangle that is similar to triangle that. AC is 3. Okay. We are doing number 2. After 2 we do number 4. Sorry, number 4. The areas of two similar triangles are that and that. If an altitude of the first one is that, 2.4, find the corresponding altitude. Same thing. I told you the area of the triangle, the area of the triangle is equal to the square of the altitude. The area of the triangle is equal to the square of the altitude. Okay, go back to the theorem. So the area is given over there as 36 and 25. The first one is 36, the second one is 25. If the altitude of the first one, so this is the first one, 2.4 whole square by x square. Find out x. Is that okay? Chalo. 5b. Okay, 5b. Look at that. Okay, that's the figure over there. I've given all the values, whatever is there according to the book. Okay, they say prove that triangle OAB is similar to ODC. I've written over here, prove that triangles are similar. Okay, mention the angles. The angles already mentioned over here. I haven't proved it similar. I haven't written the similarity. You do the similarity. You must write the similarity before you go on to the ratios. You cannot write the ratios without doing the similarity. I'm just skipping it because it's very simple. Okay, this and this is alternate. This and this is alternate. This and this is vertically opposite. Put the thing in order. Okay, I think I have put it already in order. AOB. Look at that. AOB. Cross dot tick. Okay, cross dot tick. COD. I have put them in order. But before you write the order over here, as I said, you have to prove the angles equal. Then write the ratio, put the values, and then you find OB and CD. See, taking this one, you can find OB. And taking this and this one, you can find CD. This is equal to this, you'll find CD. This is equal to this, you'll find OB. Okay, and then it says there's another part to it. Find the ratio of triangle that is to triangle that. Okay, triangle that by triangle that. If you're getting already, see over here, I'm getting 2 by 1. I'm getting, cancel this is coming to 2 by 1. So triangle that by triangle that is 2 by 1 whole square, that is 4:1. Did you get that? Right? Simple. 6b. Okay, it's given over there. 6b. Sorry. Follow the book, please. Always follow the book. Okay, I am following the book. Okay, in 6b, DE is parallel to BC. Okay, AD is to DB is 1:2. Okay, Find the ratio of area that and trapezium that. Okay, there. AD is to DB. AD is to DB is 1 is to 2. Okay. And all right, we carry on. Look at this. They have given over here AD is to DB is 1 is to 2. So AD is to AB will be 1 is to 3. That's what I have done here. If AB is to AD is to AB, sorry, AD is to DB, AD is to DB is 1 is to 2, then AD is to AB will be 1 is to 3. That's what I have done over here. Okay, and then you get the triangle that by triangle that. Okay, see, they have already said, no, they haven't said it's in the figure 2 given below so and so. No, they haven't said it's what is that? Similar. They haven't said it's similar, so you prove it similar. Okay, you prove it similar. Okay, here this angle equals this angle corresponding, this angle equals this angle corresponding. Write the triangles in order, that and that similar. Therefore AD by AB. Now AD by AB 1 by 3 whole square. Okay, you got the idea, right? AD by AB is 1 by 3 whole square. Now the trapezium, look at the trapezium. The trapezium is, okay, DBCE. That is the big triangle ABC minus the small one. So 9 minus 1, you get 8. So triangle ADE by trapezium that is 1 by 8. This trapezium is over here. I have done it as I was explaining in the theory. Is it okay? Right. We go to number 8. Check number 8. In the figure given below, fine, I have given everything over there. All the things I have marked over there. Now again, as I said, prove triangle ABC and triangle DEC similar. You have to prove it similar before you go on to the ratios. Okay? Prove it similar. Triangle ABC, triangle DEE, and it's the same thing again and again. See, 90, 90, corresponding, anything, and this is common, and so on. And write the triangle in order. Okay. Once you get the thing in order, write the ratios. Then triangle that, triangle ABC by triangle DEC. Okay? You get one ratio over there as DE by AB. Okay? Which is, or AB by DE. Right? Over here. AB by DE, which is 6 by 4, cancel it, 3 by 2, alright, and then square it. Square it, you get 9 by 4. Okay? You get 9 by 4. Find the ratio of triangle that. Okay? And then calculating CD, to calculate CD, in this ratio you substitute. In this ratio you substitute this by this is 4 and this is 15 given, AC is 15 given, you'll get DC. Using this much, okay, you get your DC. To get the ratio, okay, only 6 by 4 is enough. Any one ratio, because all the ratios are same. 6 by 4, cancel it, 3 by 2, square it, 9 by 4. Okay, everybody, chalo. Number 10. Parallelogram PQR. Parallelogram that's a parallelogram. No, sorry. Number 10. Triangle PQR. MN is parallel to that. And it's given over there. PM by MQ. It's given over there. PM by MQ is equal to 2 by 3. Fine. Find MN by QR. Okay. Right. It's given over here. There. PM by MQ. PM by MQ is 2 by 3. Okay. Prove triangle OMN. Okay. OMN and OQR similar. Prove these two triangles, this and this. Okay. Alternate, vertically opposite, similar. Finished. Is that okay? Right? After proving it similar, you write the ratio over there. Write the ratio. Okay? Sorry. And that's for the second part. Actually, that's for the second part. Look at the first part is here. Okay? Sorry, that's for the second part. The first part is here. Prove that triangle OMN. Okay, the first part is here. To find MN by QR. Okay, you prove PMN, PMN, PMN and PQ are similar. PMN and PQ are similar. Okay, corresponding. Okay, because they are parallel. Therefore, the triangles are similar. Therefore, PM by PQ, PM by PQ is equal to MN by QR. So PM by PQ is 2 by 5. PM by PQ is 2 by whole thing 5. So MN by QR is also 5. Is that okay? 2 by 5. Did you get that? And the second part over there, the second part, prove that triangle OMN, fine, here. You have to prove it similar. That's the second part. Okay, triangle this and triangle this, you have to prove it similar. That's very simple. Alternate, vertically opposite, similar. Finish. That's the second part. And after getting that, write the ratio here. Write the ratio over here. Okay, right? According to the triangle, write the ratio over here. This is done here. Huh? That's why I've given an arrow over here. Right? Write the ratio, and in that ratio you will get a ratio Mn by Qr. See, Mn by Qr. Now Mn by Qr is 2 by 5. So all of these are 2 by 5, 2 by 5, 2 by 5. So triangle that by triangle that is 2 by 5 whole square, which is 4 by 25. Is it okay? Now we go on to number 12A. 12A. All right. 12A. All right, pay attention. 12A, right? It's given over there. It's given over there that ABCD is a trapezium, and if it's a trapezium, then this and this is parallel. Okay, AB is parallel to DC, fine, and it's already also given that AB is equal to 2CD. AB is equal to 2CD, so AB by CD is 2 by 1. Okay, and then determine the ratio of triangle AOB by COD. Yeah, that's very simple. Okay, alternate, vertically opposite, similar, prove it similar as I said. Okay, I haven't done it, you'll have to do it. Write the angles similar, write the ratios, and therefore you get 2 by 1. In one place you'll be getting 2 by 1. Therefore triangle that by triangle that is 4 by 1. Simple. Okay, same thing again and again. Alright, pay attention. 12C. 12C. In the figure given below, ABCD is a parallelogram. You can see that E is a point on AB, C intersect so and so. They intersect at O, and EF is parallel to that. Everything given. If AE is to EB, can you see that? AE is to EB. AE is to EB is 2 is to 3. 2 is to 3. I have taken it as 2x and 3x. AE is to EB is 2 is to 3. I have taken it as 2x and 3x. Fine. Find EF by AD. Okay. So AE is to EB is 2 is to 3. Now prove that triangle ABD. Can you see that? ABD and EBF. ABD and EBF, you prove it similar by corresponding and all that. Is it okay? You prove it similar. Then you write the ratio, and there you will get a ratio 3 is to 5. 3x is to 5x. Okay? It is, what is your question? To find out EF is to AD. EF is to AD. Now EF comes in this part over here 3x, and AD comes for the big one, so 3x by 5x. Okay, cancel 3 by 5. Got the first part? The second part, area of triangle BEF is to area of triangle ADB. Same thing. BEF is to ABD. Same thing, okay? You take any one of the ratios because all the ratios are same. BE by BA, okay? Just square it, 9 by 25. Same thing again and again. And then again, area of triangle that to trapezium that. Same thing, okay? Area of triangle ABD, okay, to trapezium AEFD. So the big triangle minus the small triangle. Okay. ABD is 25 and this one is 25 minus 9. 25 minus 9, you get 25 by 16. Finished. Very simple. Same thing, same thing, same thing. Then area of triangle FEO is to area of triangle OBC. FEO, okay. Then triangle, now to prove FEO, what is it? FEO and OBC, you have to prove it similar. Alternate, 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 alternate. Therefore, similar. Write the ratio, and over there you'll be getting a ratio EF by BC. Okay, EF by BC. Now, BC, because it's a parallelogram, BC is the same as AD. So, EF by BC is the same as EF by AD. Do you get that? EF by BC is the same as EF by AD because AD and BC. So that also comes out to be 3 by 5. Square it, you get 9 by 25. Is that okay? Right. Now we come to sum number 14B. 14B. This I made a bit of a mess over here. Okay. But no big deal. Okay. Right. Okay. You have to prove that it's given over there. AB is equal to 2DC. AB is equal to 2DC. So AB by DC is 2 by 1. 2 by 1. 2 by 1. Okay. Prove triangle. Prove triangle AEB similar to DCE. No big deal. Now this is 3 and 4 is given. 3 and 4 is given over there. Okay. 16B. Yeah. 3 and 4 is given. Okay. And they have, now this I write it as X and Y. Got it? Okay. So I have proved it similar. Okay. After proving it similar, you write the ratio AE by DE is equal to BE by CE is equal to AB by DC. And wherever there is AE, 3 plus X. Then you have by X. 3 plus X by X. Okay. 4 plus Y by Y is equal to 2 by 1. Okay. Because AB by DC is 2 by 1. Right. And then you solve. And then you solve. This is equal to this, you'll get your X. This is equal to this, you get your Y. Am I clear there? Okay, we go to 16. All right, we go to 16. Great. Let me see, 16. Push it here. All right, there. 16. Okay, look at the figure over there. This angle is given 90 equal. This is common. So the third angle will be what is for this triangle, this angle, for the big triangle, the third angle. The third angle will be equal. Anyway, you just have to write 2. Okay, this and this, this and this, and this. This is enough. Okay, and then write the ratio, and you get the ratio PQ by PS. This angle this side, this angle this side is equal to 5 by 2. Square it, 25 by 4. Okay. Prove, the first part is proving. The first part is proving PQR similar to CPST. Now that's very kiddish. Okay, same thing. Okay, 90, 90. This is common, similar. Finish. Okay. Then you write the ratio, you get this, and then you know what to do with the quadrilateral. You know that. Okay, triangle PQR by quadrilateral SRQT. Now SRQT is the big triangle minus the small one. Same thing, 25 minus 4. Is it okay? Right. Now we go on to 17. Look at that. 17. Okay. 17. Sorry. That is not 17. This is 18. This is actually question number 18. 17, you have to do it on your own. Check it out. We can help you out also. Okay. Anyway, now it says two isosceles triangle have equal vertical angles. Okay. These are two isosceles triangle. This side equals this side. This side equals this side. And the vertical angles are equal. Okay. have vertical angles, and the area is in the ratio 7:36. 7:16, sorry. The area is in the ratio 7:16. Find the ratio of the corresponding heights. That means you have to find out this ratio of the corresponding heights. I told you, okay, now angle A is equal to angle P given. Okay, now AB by PQ, because they are equal, is 1 by 1. AC by PR is 1 by 1, because they are equal, ratio is equal. Triangle ABC by triangle PQR is equal to AD square by PY square. Triangle ABC by triangle PQR is AD square by PY square. Is that okay? Which is equal to 7 by 16 given. Okay. So AD by PR, you take the square root, is root 7 by 4. Very simple. Right? They said find the ratio of the corresponding heights. So AD by PR is take the square root, the square goes over here, it is root 7 by 4. Okay, so much so about this part of the sum. I'm doing that map and all that in another video. Okay, check that out. Okay, I'm just keeping that separate for the time being. Right? Okay, thank you.